Hello and welcome to this month's Office Hours by BYK Instruments. My name is John Kowalski. I'm part of the marketing team here at BYK Instruments and like to welcome you. Today's topic is an introduction to color theory. If you're unfamiliar with our Office Hours format, it's a little different than the traditional webinars. We give a shortened presentation, usually 20-25 minutes, then it's just followed by questions, discussions that you, the audience, drive. So if you do have a question, a challenge that you're facing in your own facilities, something that's bugging you, please log it in the chat box and we'll get to it immediately following the presentation. Also, we are recording this, and immediately following, you'll receive an automated email from the marketing team with a link to the recording. Feel free to watch this at a later date or share it with colleagues, whatever you like. Today's presentation is our presenter is going to be Ray Roby. She's our business line manager for automotive and one of the many color experts here at BYK Instruments. So without further ado, Ray, it's all yours.
Hello, good afternoon, everyone. So today we're going to do basic color theory. And we're going to start, one second, if I get my thing in the right way.
There you go.
Okay. So for color perception, what we have is we have a light source, we have an observer, and we have an object. And all these things are very important because without one, you can't really define color. So when we talk about illuminance, the illuminant that we use most of the time in automotive and most of the industries across the US and Canada would be D65, which is daylight. And the reason that we use D65 is because it contains all of the visual spectrum. So 400 to a little over 700 nanometers of light. There's different illuminants that you can have. Some of the standard illuminants are D65, which I just talked about is daylight. A is tungsten. So this would be like the bulbs that you have in your home that have a little bit of a pinker hue to them. Then F2 would be fluorescence, which is usually greener and bluer. So under different lighting conditions or different illuminants, you can see different things. And the reason that we use D65, the daylight illuminant, is if you look here at the structure spectrum, you can see that over all of the different colors, it's the most uniform. If you look at the A for the tungsten, most of the energy that's coming back to your eye is in the red area. That's why it's giving it a red hue. Then for fluorescence, there's a lot in the green where it spikes and also in the blue where it spikes. So why is it important that we look at different colors or all the colors under different illuminants is because we could have a condition called metamerism. And metamerism is where you can see a good visual match under certain lighting conditions, and then under other lighting conditions, you could have a mismatch. And just an example from automotive, if we have metamerism on a vehicle, and usually the higher end vehicles are the ones that are in the showrooms. And then if you didn't look at this color under multiple light sources in the showroom, you could have the potential of a mismatch, which is where most of your customers are going to be looking at the higher end cars. Even though under daylight, you could see a perfect match. And we have something in the instruments called a metamerism index, MI index. And usually if this is under 1, you have no metamerism. If it's over 1, you have the potential to have metamerism, but you do need to look at it visually. So we talked about the light source, and now we need to talk about the observer. And there's 2 different observers. There's a 2-degree observer and a 10-degree observer. And this is basically how much of the back of your eye is being used to see the color. So there's cone cells, which are red, green, and blue. And there are rod cells, which are the lightness, darkness detectors, and usually these are used at night. So in order to define the observer, we did an experiment called the Wright-Guild experiment, and basically you have a masking screen and a test subject on one side, and then when they look through the bottom light, the purple light, they try to adjust the 3 lights on the top, the red, green, and the blue, to match that color on the bottom of the screen. And that's how we determined the observers. So originally in 1931, a 2-degree observer was used, but then after some studies were conducted, they decided that a 10-degree observer actually corresponds better with your color perception of your eye. So here's an example of the 2-degree observer versus the 10-degree observer. So you can see there's a little bit more in the blue area on the 10-degree observer, a little bit more in the green area, and a little bit more in the red area that you can see. So when you're looking at an instrument, it's important to make sure that your illuminant is the same and also the observer is the same. Because if one person's using a 2-degree and another person's using the 10-degree observer, you're going to get slight variations in your color numbers. So now we talked about the light source and the observer, so we're going to talk about the object. And there's many things that go into the color that we see visually. There's the direct reflection or the gloss off the surface. There's also absorption pigments that absorb certain colors and release other colors. And then there's diffusion pigments that diffuse the light into different directions. So all of these go into every sample that we're measuring. So you have the light source, you have the diffuse reflection, you have the gloss, and you have the absorption pigments all in one object. So if we look at these different spectral reflectance curves, the first one, all of the light is being reflected to our eye is in the blue area. You can see on the spectral curve. The second coffee mug is red, and most of that energy is being reflected in the red area. This is probably a blue shade red because there is some blue also. The green is pretty much a straight green. All the light's being reflected in the green range. And then yellow is one of the more complicated colors. A lot of people, when we show this, think that this is going to be orange, but it's actually yellow based off of the color that we measured. So now we want to talk about the illuminant, the observer, and the object, and then how are we going to use this information to communicate color and to understand what we're looking at. So originally it was the XYZ scales, and these were also quite complicated to discuss between people or to understand what that color would actually look like. So we converted everything to LAB or C-Lab. And here is a plot for the CIE LAB system. And here you can see 0 would be a perfect black, 100 would be a perfect white. And then you have your A axis, which is red, green, and your B axis is yellow, blue. So on metallic colors, you could have an L value over 100 just because of the reflective materials in the coating. Also for C-Lab, you could also use the LCH system, which is chroma and hue, and I'll explain that to you in a little bit. So one thing that's important here is every color is defined by where it is in color space by LAB. And there's numerous equations that can be used in the industry depending on what we're trying to accomplish and what types of colors we're trying to quantify. But every single color has a location in LAB space. Also, when you talk about differences, you want to make sure that you're doing the sample minus the standard. And this is for all instruments, it's the same case. And here you have the delta E between the sample and the standard. Also the delta A, which is the red-green, the B, which is the yellow-blue, and the L, which is the lightness-darkness. And the delta E is just the square root of the sum of the squares of the delta L, delta A, and delta B. And now we're ready for questions.
And thanks, Ray. Always informative. Yeah, if anyone out there has any questions, please log them in the chat box and we'll get to them. The rest of the hour is your time. So we can help however you need us to. One question, Ray, on you mentioned metamerism, and again, it's looking at an object in under one light looks one way. You move it outside, for example, it looks a different way. What are some common causes of metamerism that manufacturers and suppliers should be, aware of and things to avoid?
So when a color comes out, say in the design process, then different automotive, well, in my case, automotive paint suppliers, or in general, paint suppliers are asked to match that color. And at that time, they don't always have all of the information about what pigments were used to match the original color. So there's times when they may use a pigment or something else in the formulation that isn't included in the main formula, and that can cause a difference in metamerism.
Nice. Let's see. It looks like we got a question here. Can we get the slides? Yes, I can send that out. Also, you'll be getting the recording as well in a link through an automated email immediately following the presentation. So other questions on this? We've covered a lot. I know there's a lot of color systems out there. Primarily, we use LAB, CIE. Is that right, Ray? Or are there different industries that use different systems for measuring?
So all the industries have a specific equation that they like to use. For automotive, the equations that we use now are all called weighted color systems, and they take the slide that I showed you where everything's defined in a certain location in color space. They take that location in color space, and based off of where you are, it defines your tolerancing automatically, and that's why it's called a weighted color system.
Nice.
Other people like to use like C-Lab or LCH, and what you need to be careful with those equations is that for every single color, you're probably going to have to be adjusting your tolerances to make sure that it works for that color. So it's not as simple as with the weighted tolerancing systems that we use. Mm-hmm. That one you have to actually do like physically by hand.
Yeah, that doesn't sound like fun at all.
And time consuming.
Yeah, very. Our next question, what's more recommended to use, LAB or LCH? And I think you answered that by steering us towards the LAB to avoid that manual work.
Well, so LAB or LCH can both be done manually because it's all the CIE system.
Okay.
It just depends on if you have a chromatic color or a non-chromatic color. So LAB is usually used for colors that are under a chroma of 10, and anything over that you should use LCH. So what it does is, because of the way the calculations are set up, when you switch to LCH, you gain some variation on your chroma axis. So that's the intensity of the color. So like if you could have like, say, a light orange, but you could have a really bright orange that's the same color, just more intense for the chroma. And the hue if you have a color that goes from, say, a yellow blue to a red blue, that's a hue shift. So it really depends on the color that you're looking at and what's going to make more sense to you.
Okay. And okay, that makes sense. When you're with customers and you kind of get into this color theory, what are common issues that you see going on in facilities? Or common mistakes, I guess I should say.
So the biggest issue that we see is either, well, many issues, but so someone's using a 2-degree observer versus a 10-degree observer, which can change your color numbers, or they're using a different light source. So if I'm measuring with D65 and you're measuring with A, we're going to get different numbers. And also, if you use different equations and you're not using the same color system, that's going to change how your numbers look.
Okay. Interesting.
And also, if there's 2 instruments for solid colors, the 45-0 and the sphere. The sphere is made more for measuring color without the impact of gloss. And the 45-0 shows more what you see visually. So if you're measuring with a 45-0 and someone else is measuring with a sphere, those numbers are not interchangeable at all. They'll be completely different.
Got it. Are there different industries that either standardize on sphere or 45-0?
So years ago, most people like to use sphere, and it's kind of an interesting reason because when you use a sphere instrument, usually your numbers are smaller. So people thought they had a better match to the standard, which if you're doing like weathering or something, that's important because you don't want to take into account the gloss change. You just want to take into account the material changes. So that was the industry normal instrument for a while. Now most people have switched to 45-0 because that shows you what you see visually. So if you're doing color harmony between any 2 parts that match up to each other, you want to use a 45-0 because that's going to give you the best to visual that you're going to see.
Okay. But in textiles, are they still standard on sphere predominantly, or have they shifted more towards the 45-0 as well?
So in automotive textiles, they're starting all to go to 45-0. I don't know about the actual textile industry itself. I can't comment on that, but
sure. Okay. No, that's good to know. So like I said, what other comments, questions, thoughts out there? We have a lot of time left. Ray's an expert, and we have some of our regional sales folks on the line as well, and they can always jump in and help. You mentioned a little bit about gloss too, and how does that play into color measurement? I know we offer, some of our spectrophotometers have gloss meters included. I know there's separate gloss meters. How should that be incorporated if that's an issue in what you're producing?
So depending on the industry that you're looking at, the gloss can have a substantial effect to the harmony of the parts to each other, especially for low gloss parts. Maybe like a 2% gloss change in a gloss under 10 gloss units is very perceptible to someone's eye. So it's important that you use the color and the gloss together to get the final harmony for the vehicle or the appliance or whatever it is.
Okay, that makes sense. What else? Color theory, fluorescent colors. How do you handle that? One, how do you tell if there's a fluorescence within the pigment? And 2, how do you measure and check that for harmonization?
So In our meter, we can measure fluorescence in the coating, and then we also have a way to measure what would be the final color position if all of the fluorescence was eliminated from the sample. So that gives you an idea if two components have different levels of fluorescence in them and they're going to change and end up two different colors over time. Obviously, you wouldn't want that in any type of, siding or patio furniture or interior automotive, any of those things. It would not be good to have one fade and the other stay the same. I mean, the best case would be they faded the same if they're going to fade at all, but hopefully there would be no fading.
Yeah.
But our instruments can predict what you're going to see, but that doesn't have anything to do with any types of weathering or anything like that. Only if all the fluorescence is eliminated from the color.
Okay. Okay, good. What, come on, folks, what questions you got here? Help me out. What else do you see in out in the field? You know, a lot of, I guess missteps or things to be aware of when you're measuring color and looking for that harmonization.
So one thing that's always kind of a problem is when you don't set your specifications correctly. So either you're not shipping parts that are technically within visual specification tolerance, or if you're shipping things that are out of tolerance.
Yeah.
So it's really, really important that you do set up for each individual color, depending on what color system you're using, and make sure that that's correct to what you see visually. Because if you set them too tight, every single measurement that you take is going to be a failure. So then people just kind of disregard it after a while because everything is failing. So why bother with looking at the number? So it's really important that you set them up correctly. And we can always help you set them up. We would just need samples that are good and bad and things like that. So we have some idea of what you consider good and bad for your industry, and then we can help you set the specifications.
Yeah, gotcha. Got a question in here from John. For a semi-transparent film, what backing should be used for a 45-0 measurement? Black, white, or a light trap? What's your recommendation?
So for me, I usually do white tiles and like buy a whole box from like Home Depot. So, they're all from the same batch so that the tiles are the same color. Because if you use different tiles, that could change your reading if the color on the tile is different. Also, you can measure the tile so that you know that it's the same or consistent with the last tile you used. And then make sure you always use the same tiles to do your measurement.
Yeah,
but other people have different ideas. That's how they do it.
That's a good idea, getting a box of the same tiles from the same batch, to keep them more consistent.
Because they do change over time if you're not careful.
Yeah, exactly. Another question, does BIC make any transmitted color measurement equipment?
No, we do not.
Why not?
Mm-mm. Unless I'm wrong. Jonathan's on. See if Jonathan knows. But I don't think any transmitted color. We do transmission and haze, but not color.
Okay. Got it. Okay, other questions out there? Just keep them coming, keep logging them in. Otherwise, Ray and I will just chat about color stuff. I know we've talked about this in other webinars and just in, as we prepare different marketing materials and documents, the importance of just the standardized process, doing everything consistently time and time again. And that's dependent, on, shift to shift, plant to plant, because then you're measuring apples to apples across the board and you're going to get consistent, reliable data. Can you talk more about that?
So for the 45-0 and the sphere instrument because they're both measuring and they're non-directional. How you measure is not like how the instrument's positioned isn't as big of a deal as on a multi-angle instrument that has for like metallic flakes and stuff like that, because the color flakes really affect your measurements if you're not holding the instrument in the same position all the time.
Mm-hmm.
And you want to try to measure the same location as closely as possible every time that you measure. And back to the other things like making sure the same color system and the same illuminance and the same observer, all those things are very important.
Good. And even, it's the location, but also, I know you deal with this a lot in automotive when you're outside on a lot. It depends on the time of the year, the position of the sun, where you are, where you're located in the world and where your suppliers are too. That all takes into account, correct?
So that's your visual impression. The instrument's always measuring the same, but
Okay.
it's important that when you measure on a car body, for instance, the sun is always coming from above you. And so you want to make sure that the instrument, the light source is also coming from the same direction. So it's matching as close to what you see visually as possible.
Good. And visual color analysis, how does that play in, with you using instrumentation? It should be, side by side, and you should do both. Is that an accurate statement?
So what I recommend is that we look at the vehicle for automotive first, and then kind of make our decisions, and then look at the color data to decide what we want to do with the information that we have. Because sometimes people look at the data first and they already have that in their mind, and then they see the car that way instead of looking at it to see what the customer experience would actually be, because that's more important than what the numbers say. So you could have colors that don't match the standard but actually look good to each other, so that's still a shippable part or vehicle. And then you need to get back to standard just so that you're matching to the standard, but there's different levels of what's shippable and not shippable. And every industry for what's okay and not okay is totally different. So that's why we would need the customer's experience to understand how to help them set their tolerancing to make sure that we're matching what their industry expectations are.
Yeah, because every industry is going to have a different acceptable tolerance.
And automotive is usually the tightest out of all the industries. So the equations are very specific, and it's, not the easiest to match under those color systems, but it keeps the vehicle looking nice for harmony. So that's a good thing.
Exactly, especially when you have different substrates, bumped up against each other, like a bumper and a hood or a quarter panel.
And things are usually not sprayed the same or have different materials sprayed on them.
Yeah.
And they all have to, in the end, match. So that's quite a challenge.
Yeah, and if it doesn't match, that vehicle's has a small chance to get sold and ends up sitting on the lot. So it really goes down to that that consumer level and just that visual appearance, on a car lot, looking at orange juice, at your grocery store. If something, looks a little off color, people aren't going to pick that because I think there's something wrong with it, even though, it may be a, perfect product. Color may be off. So very important.
It's all about perception of quality. And if the color doesn't look the same, like you said, in orange juice, for example, if you had one that was a little bit maybe lighter than all the rest, you would think maybe it's watered down or something's wrong with it, right?
Yep.
And it totally affects your purchasing decisions.
Yep. Very nice.
For every industry. So.
Yep. Very true. So what else, folks? Questions out there? Are you having any specific challenges at your facility with a part or multiple parts? We have a little bit of time left here. Want to use this time as best we can to help you all here. Just note too, you'll get a recording of this immediately following this. Or if you think of a question, later today, next week, whenever, you can hit reply to any of the marketing messages you receive, and it'll come to my team, and we'll get it to the technical expert, or one of the regional representatives in your area. So Ray, what else are you seeing out there kind of around this topic of, instrumentation, fluorescence, metamerism, looking at different effect pigments? What else are you seeing out there as trending?
So in the beginning, metamerism was less of an issue, or it was caught farther upstream. And recently we've been seeing some of the metamerism issues actually to getting on the vehicles themselves, which is not normal. So that's a new trend. And I don't know if it's because of all of the modifications to the formulas that we had to make due to sourcing issues.
Yeah, because the raw materials and chemicals in the paints and pigments, that if there's fluorescence or something in there, that could be a key cause of metamerism. Yeah.
Yep. So I think that's why we're seeing like an upsurge in it. And normally it would have been caught in the past before it even got to the plants, but it seems like it's happening more and more now. So that's one thing that.
Yeah, it makes total sense with the supply issues. Everyone was scrambling for raw materials, and they might have gotten some substandard stuff just because that was the only thing available, and it's been sitting around since the COVID pandemic, and now it's moving its way into the production systems.
Yep, I agree. That's totally one of the bigger reasons. But also we know that it causes big problems because, again, if you have something look different under, fluorescent lights rather than outside, you're going to have an issue because people are also going to see that as a quality issue.
Right.
And I think that's the biggest thing for color, that people who are buying the products, when they see something that's not uniform, they don't like it, so they're not going to pay money for it. Yep, or exactly. They just assume it's low quality and they just walk away,
Yep, very true.
It could very be true. Or anything,
Yeah, well, we don't have any other questions in here. We can give it another minute here. I know we're all busy, and you all probably have, work and real stuff to do, but we're here to help with any of your color, appearance, physical test equipment needs. Like I said, you'll get the recording. Stay tuned for future BYK Instrument office hours. I believe next month is appearance theory, so it kind of goes hand in hand with color theory. And I know next week we have a full 60-minute seminar on dispersion and media milling for energy storage. So if you're in the battery market, take a look at that one. But thank you, Ray. I want to appreciate your time, your expertise, sharing it with everybody today. So thank you. Everyone on the phone, thank you for joining us. Like I said, if you have any questions after the fact, just hit reply to any of the marketing messages, and we'll route it to Ray or one of our technical or regional specialists. So with that, have a great rest of your day, and we'll see you on future BYK Instrument webinars. Thank you.
Thank you.